8 hours, 4 countries, 4 earthquakes. At 11:10 in the morning Eastern Time on June 24, 2026, the ground cracked open near Ukiah, California, a magnitude 5.6 on the Macama Fault, part of the broader San Andreas system, strong enough to send shake alert notifications to phones across the Bay Area and generate a statement from the governor's office within hours. 6 hours and 54 minutes later, at 6:04 in the evening, Venezuela convulsed. Magnitude 7.2. 39 seconds of silence, the time it takes to pour a glass of water, to read a single paragraph, to exhale and inhale once. Then magnitude 7.5. Buildings that had stood for decades collapsed in seconds. Over 4,000 people are dead. Tens of thousands remain missing. Minutes after that, a magnitude 6.9 struck offshore Japan, near Kuji in Iwate Prefecture, the same Sanriku coast, the same subduction zone, the same fault geometry that produced the 2011 Tohoku earthquake and killed 18,000 people. And throughout the same 24-hour window, the Philippines registered multiple magnitude 5 events along the Cotabato Trench, the fault system that produced the strongest earthquake in Philippine history in 1976. 4 tectonic systems, 4 separate plate boundaries, 4 distinct geological mechanisms. 8 hours. The question that dominated global news coverage in the 24 hours that followed was the obvious one. Are these events connected? And the scientists who were asked that question gave the same answer, clearly and consistently. Probably not. William Barnhart, a USGS geodesist, told the New York Times the California and Venezuela events were most likely coincidental. Russian geophysicist Pyotr Shebelin described the Venezuelan and Japanese earthquakes as pure coincidence, with no pattern connecting them. Mark Quigley at the University of Melbourne confirmed that the Venezuelan doublet likely triggered itself, the M7.2 causing the M7.5, but found no evidence of any physical relationship to the California or Japanese events. The USGS was direct. Most major earthquakes are driven by local tectonic conditions rather than a single global mechanism. These are the scientists. They are right to be careful. They are right to resist the narrative that a single event in Venezuela somehow triggered earthquakes on the other side of the planet. The evidence for direct causal connections across those distances does not exist in the June 24th data. But here is what the scientists cannot say. They cannot say that the stress levels on these 4 fault systems are declining. They cannot say that any of the tectonic systems that moved on June 24th are less dangerous today than they were the day before those earthquakes. And they cannot say that the coincidence of multiple M7-class earthquakes occurring within a single calendar year on fault systems that were each independently already at historically elevated stress levels is a reason for reassurance rather than attention. Because the question the scientists answered is not the question that matters most. They answered, are these events directly connected? The answer is, probably not. The question that matters is, what does the state of the planet's major fault systems look like in 2026, viewed as a whole? And that question has a different answer entirely. Venezuela's M7.5 doublet struck the San Sebastian fault system, a right lateral strike-slip boundary between the Caribbean plate and the South American plate that had not produced an earthquake of this magnitude since 1900. The stress that released on June 24th had been accumulating for 126 years. The USGS finite fault rupture model shows the earthquake ruptured a fault approximately 175 kilometers long by 20 kilometers wide, the largest rupture in Venezuela's modern geological record. The Boconó Fault, adjacent to the rupture zone, is still loaded. Scientists estimate it has accumulated enough slip deficit to produce a magnitude 7.0 to 7.6 earthquake entirely on its own. The June 24th doublet did not discharge the Venezuelan fault system. It discharged one segment of it. Japan's M6.9, which struck offshore Iwate hours after Venezuela, occurred in the Japan Trench subduction zone, where the Pacific plate dives beneath northeastern Japan at nearly 9 centimeters per year. The Japan Meteorological Agency had already announced, following a magnitude 7.7 earthquake in April 2026, that the probability of a megaquake in this same region had increased tenfold over background levels. The M6.9 on June 24th did not resolve that elevated probability. It added to the aftershock catalog of a fault system that seismologists are already watching with maximum attention. The Nankai Trough, a separate but structurally related subduction zone along Japan's Pacific coast, has not produced a major earthquake since 1946. Japanese government models estimate it will kill between 32,000 and 323,000 people when it does. The Philippines' M5+ events along the Cotabato Trench occurred on a fault system that produced an M7.8 earthquake on June 8, 2026, just 16 days before Venezuela. That June 8th event was the strongest earthquake to strike the Philippines since 1976. The Cotabato Trench has been generating elevated aftershock activity since June 8th, and the events registered on June 24th are part of a fault system that is demonstrably in an elevated state of activity. California's M5.6 near Ukiah on June 24th struck the Macama Fault, a component of the broader Northern California fault network that includes the Rogers Creek Fault, the Hayward Fault, and the San Andreas itself. Less than 3 weeks later, a magnitude 4.3 struck near Ridgecrest in Southern California. A magnitude 4.4 struck Valencia in LA County at 3 a.m. And the Burkhardt study, published in June 2026, confirmed that the combined San Andreas and San Jacinto fault systems are now at their highest stress levels in 1,000 years. Stop for a moment. Not to speculate about connections between events, but to describe what these four tectonic systems have in common, independent of whether they influenced each other on June 24th. Each of these systems was already stressed before June 24th. Venezuela's San Sebastian and Boconó faults had been accumulating strain since 1900. Japan's Sanriku and Nankai systems have been building pressure since 2011 and 1946, respectively. The Philippines' Cotabato Trench ruptured at M7.8 just 16 days prior. California's fault network is confirmed to be at a millennium high for stress levels. The earthquakes of June 24th did not create these conditions. The conditions existed before June 24th. The earthquake simply revealed, in a single 8-hour window, that 4 of the world's most dangerous fault systems were all, simultaneously, capable of producing major seismic events at exactly the same moment in geological time. And there is one more dimension to this picture that the news coverage of June 24th almost entirely missed. A new study published in the Times of India this week describes research showing that seismic waves from Japan's 2011 M9.0 Tohoku earthquake traveled 2,900 kilometers to the boundary of Earth's outer core, reflected back 13 minutes later, and moved the entire country of Japan eastward by 6 millimeters, a phenomenon detected by GPS networks across the country simultaneously. This was the first recorded observation of this phenomenon. What it tells scientists is that seismic energy from large earthquakes does not simply dissipate at the surface. It propagates through the deep interior of the planet in ways that are only now being fully measured and understood. The Venezuela Doublet, magnitude 7.5, releasing energy equivalent to 6.8 atomic bombs, produced surface waves that circled the Earth multiple times. What those waves did to the deep structure of the planet's fault systems, on timescales and at depths that monitoring networks cannot yet fully resolve, remains an open question. The scientists are right to say June 24th was probably coincidence. Coincidence, in seismology, does not mean safe. It means the faults moved independently, on their own schedules, driven by their own locally accumulated stress. The Boconó Fault did not need Japan to move. Japan's Sanriku Zone did not need Venezuela to move. The Cotabato Trench did not need California to move. Each of these systems had enough stress, enough accumulated strain, enough geological justification to produce major earthquakes entirely on its own. That is not a coincidence that makes anyone safer. It is a coincidence that makes the global seismic picture more dangerous than any single event would suggest. Because if these 4 systems moved independently, without triggering each other, on the same day, then there is no requirement for a global trigger to produce the next event. The next major earthquake on any of these faults can happen at any time, on its own schedule, on its own terms, without waiting for anything else to move first. June 24, 2026, was not the beginning of a connected seismic crisis. It was a window, 8 hours wide, through which the state of the planet's fault systems became briefly and simultaneously visible. What the window revealed is that multiple systems on multiple continents are loaded, stressed, and capable of major rupture at the same time. Not because they triggered each other, because each of them, independently, has been building toward this point for decades, some for over a century. The scientists are correct. These events were probably not connected. But the fault systems that produced them are all still there, still loaded, still building, still moving on their own schedules, toward their own breaking points, without waiting for anything or anyone to give them permission. That is what is not normal. Not the coincidence of the events themselves, the state of the systems that produced them. Subscribe to Seismic Alert. We will keep the window open.